Okay, so we're going to do some hard examples now, specifically examples that are going to push us to the limits of being able to make decent drawings of the kinds of figures that will be relevant in courses like multivariable calculus. Okay, so the first one, and this is a tricky one, we're going to talk about the unit circle. Now that sounds easy. It's the unit circle on the xy plane, but specifically sitting inside of 3 space. So this is what's going to make it challenging. We're not going to be looking at it sort of straight on, and we want to try to figure out how can we represent this unit circle and the fact that it is lying down in the xy plane. Okay, so here we go. So let's draw the 3-dimensional axis system here. Oh, missed. Let's try that again. There we go. Okay, so x-axis, y-axis, z-axis, and as a first attempt, now just as a reference point, there's our origin. First attempt to draw the unit circle, we might do something kind of like that. And this just doesn't look right. It doesn't look like it's lying down in the xy plane. There's some terribly bad features of this drawing, and it just does not convey what we want it to convey. Okay, so let's try to identify what is it that's bad about this. What's bad about that is an issue of parallelness. Now let's look in the xy plane. There's the xy plane. I'm going to come over to here. I'm going to draw the xy plane looking sort of straight on at it. Here's the xy plane. We're looking straight on at it. The unit circle, something like this. And there are some things in this picture here that are parallel to other things in this picture, importantly. So here we go. At this point, there is a direction that the curve is going at that point. The curve is parallel to that line. Right, so the direction of the circle there specifically then is parallel to the x-axis. Right? So along those lines, then let's come back in here into our 3-dimensional picture, our first attempt at a 3-dimensional picture, and we did something like this. Right? That point at the, where this unit circle intersects the y-axis, at that point, that tangent line is supposed to be parallel to the x-axis. So I'd better draw the circle here in such a way that it's parallel to the x-axis, and notice that is dramatically poor in this example. That tangent line at that point is nowhere close to parallel to that axis. And that and similar faults in this first whack at a picture, that's why it doesn't look good. That's why it doesn't look like it's lying down in the plane. What is parallel does not look parallel. Okay, so let's take a better attempt at it. Coming down here, give ourselves some extra space. Do a better job here. There we go. Here's an axis system. This, let's label our axes. This circle, when I draw it here, when it goes through that point, at that point, it needs to be going, remember, parallel to the x-axis. So it needs to be doing kind of like that. So as I draw this circle, when I get to here, it needs to be doing something like that. Okay. So likewise for other points along this circle, it's not hard to persuade yourself that at that point, the circle needs to be the tangent line to the circle needs to be parallel to the y-axis. Right? That's how it actually looks in the plane, so it had better continue to look that way when I draw it in 3 space. So it needs to be kind of like that over there. At a point over here, where the circle that I'm going to try to draw intersects the negative part of the y-axis. Well, again, at that point, it needs to actually be parallel to the x-axis. Therefore, I better draw something that looks parallel to the x-axis. Something kind of like that. And then ditto over here. It needs to look parallel. It is parallel to that, so it needs to look parallel to that, and so it'll be something kind of like that. Okay, so now doing a perfect job with this is going to require a certain amount of actual artistic skill, and this is where we mortals are going to not do a perfect job, and so we need to accept imperfection as unavoidable. But keeping in mind this point, we can do a better job than we perhaps otherwise would. So here we go. I'm going to start at this point and start going around that way. From here, I've got to start going parallel to that axis. And I need to get to this point now, but I don't want to get to this point, that way. That'll have me going the wrong way. I need to get to that point parallel to that axis. So I need to approach that point in there like that. So it'll be something kind of like that. Let me see if I can do a little better than that. Maybe something like that. Okay. Likewise, now when I get to this point here, I need to be coming that way. Weirdly, when I leave this point, there's a temptation to kind of go over to where you need to get to, but notice that has you again going the wrong way. I need to leave this point going parallel to that axis. So I have to kind of keep going that way, and I'm going to have to kind of curve back over there. Okay, so let's try the whole thing then from the start. Something like that. Now this isn't perfect. It's got a little bit of a lumpiness and bumpiness to it, and that's too bad. But if you think in these terms, and now I'm going to clear this whole thing out and try to just do this all at once. You think in those terms, keep in mind about which direction you're supposed to be going at which point in your drawing of your circle. You can do a decent job. There we go. Now, that's not perfect. Let me critique myself here. I've got a weird little sort of bump in it there due to sort of going too slow. There's a certain amount of wamble in my line right there. But overall, big picture, this looks a lot more like it's lying down in the plane. And you might think in terms of, again, what should be parallel to what, and did I achieve that? At this point, I'm going about like that, and that's not perfectly parallel to that, but it's pretty close. It's not that far off. At this point, again, not perfectly parallel, but pretty close. Likewise, here, something like that, that's pretty good. And then there, well, maybe I didn't get that quite right. Maybe that's angled a little bit too far down, but pretty close. So this is going to make a big difference in how your curves look when you're drawing them sitting inside of angled planes. And keep it in mind that as you go along drawing it, you've got to be thinking about what is supposed to be parallel to what as you go. Okay. All right. So let's go to the next challenge now. Our next hard picture. I'm going to draw a quarter paraboloid. Now, y'all will recall we talked about how to draw paraboloids, and roughly speaking, something like that. That's, approximately, it's figuratively correct, qualitatively correct, you might say. But suppose I want to draw just a quarter of that, just a piece. So how would I draw just a quarter of this? Well, I might think in terms of cutting it in half that way, and then cutting it in half in a different direction, like something like that. So cut it the one way and then cut it the other way. And now in particular then, I'm going to be slicing it like that and that. And we'll be looking at sort of what's left over. So now let's think about how this vertical plane here, how's that going to intersect with our paraboloid? Well, a plane intersecting with the paraboloid, that cross section is going to be a sort of a parabola. And then likewise over here, this plane intersecting with that paraboloid is going to make this other parabola. So we're going to have something that's in the ballpark of this shape right here. This is kind of what we're talking about. This is our quarter paraboloid. Okay, so I'd like to do a more detailed job of that. Let's do this specifically on an axis system. Let's look at in the first octant. Let's be more careful. That line there. In the first octant. Okay. And let's think about now that that paraboloid, how it's going to look sitting inside of the first octant. And let's draw the relevant parabolas. By the way, here's the paraboloid I want to draw. There's a paraboloid. Right? And let's look at the part that sits inside of again this first octant. Okay, so let's start off with what does that look like inside of that plane? Well, this plane is the plane y equals 0. If you were to take y equals 0 and put it into there, combining these equations, in other words, notice that the intersection of these two surfaces, namely the y equals 0 cross-section of that paraboloid, is going to have an equation in that plane which is just z equals x squared. So that's a parabola. So I need to draw this parabola sitting inside of that blue plane. Okay, so how are we going to do that? Parabola sitting inside of that blue plane. Well, you could plug in some points. We know it goes through the origin. We know it goes through the point 1, 1. Well, 1, 0, 1. So x equals 1, z equals 1. Okay. And then parabola. And parabolas kind of do sort of like that. Right? Now, bad picture. This little curve that I just drew here is actually pretty bad. Let me tell you why. What is it that's bad about this? I just drew that curve kind of going straight down to that point. Notice I have it going in at a pretty sharp angle. It's crossing the x-axis at that sharp angle. Well, that's not what parabolas do. Right? Let's think about that again. Let's look at it from a different angle. That same parabola, looking at that same plane here, but now looking at it straight on. There's the origin. Here's this point 1, 1. It doesn't just go straight there. It's z equals x squared. It's going to come in and it's going to be tangent. It's going to be tangent to the x-axis at the origin. Okay, so I can't just sort of put a little curve in it and otherwise just head straight for the origin. When I get to the origin, I've got to be moving that way. And again, that seems weird. I'm coming from above it, but when I get to it, I have to be coming from below. So it seems backwards, right? But that's what you have to do. So here we go. I'm going to come down like this and sort of go in, again, trying to draw it tangent to the x-axis there. And let me see if I can do a little bit better job here now. Something like that. And I think that's pretty decent. Okay. All right, so again, very important point. Think about what's supposed to be tangent to what, and then make sure that that is accurately reflected in your drawing. Okay. All right. So next thing, let's look at this paraboloid that I'm trying to draw again. And so this is what we're trying to draw. And let's think about what is going on inside of this plane. How does the sort of this back face of our quarter paraboloid, what is that going to look like? Well, that back face has equation x equals 0. Right? The intersection that I get by combining these equations, that's a curve, and I get that by, well, putting that into there. And note the equation becomes z equals y squared. So again, I get a parabola inside of this blue plane, and that parabola, well, again, it's pretty easy to draw. It's just a matter of, you know, notice it goes through the origin, notice it goes through that point, and it's a parabola, and so it's going to be kind of like that. Okay. All right. Now, what else is going on here? What else can I say about, you know, what I'm interested in? Well, there's going to be a back face. How this intersects is going to make a face about like that. This line here needs to be parallel to the x-axis. So let's draw it as such. And here we go. That's reasonably competent as being parallel to the x-axis there. Not perfect, it's pretty close. Okay, I now see a problem with my picture. I've got a big problem here because this point here is supposed to be 0, 1, 1. This point here is supposed to be 0, 0, 1, and therefore these are supposed to be connected by a horizontal line. They're supposed to be connected by a line that's parallel to this axis. And what I've got drawn doesn't do it. Right? So this picture that I've drawn is flawed as I've drawn it, and I can't just leave it as it is. There's a temptation when you're drawing figures to think, well, I've already kind of committed myself to, you know, this being where it is, and I just have to kind of make do with that because, my gosh, I couldn't possibly erase it. And that's a mistake. If you discover that you've done something that's simply not accurate, independent of who's to blame, nothing wrong with that. Right? Redraw your picture. Okay, so that's what I'm going to do here. I'm going to redraw that paraboloid. I'm going to recognize that I drew this sort of too far down, that starting point. I started it just too low, so I need to bring that up. After all, I am going to need to be able to connect with an edge that's parallel to this, to that y-axis. And so with that in mind, I'm going to start here, not there, right? We're going to start up here now, and again, draw my parabola that I previously kind of messed up. Something like that. Okay, all right, now that is starting to look a little bit better. Okay. All right, so now what's missing? We're supposed to be drawing part of a paraboloid. I've drawn some of the edges. We've drawn that edge. I've drawn that edge. There is, however, of course, another edge here somewhere. And now let's figure out what's going on with that edge. Okay. Well, where does that edge come from? Well, that is where this horizontal plane intersects with our paraboloid. That horizontal plane has equation z equals some constant, depending on how high I wanted to go up, but maybe 1, for example. Combine these two equations, put that into there, and what comes out is c equals x squared plus y squared. And of course, y'all will recognize that. The combination of these two equations, recognize this as being a circle. That's the equation of a circle. So this last edge that I need to draw here, this edge needs to be a part of a circle. Now, quarter circle specifically. Now, again, there's a temptation to put a little too much round on it. After all, it's supposed to be a quarter circle. I'm supposed to be moving a full 90 degrees, so don't I need to do something like that? Well, absolutely no. In the picture that we're trying to draw, we know that that circle, its tangent line at that point, needs to be parallel to that. Right? So this would be a completely wrong picture. So I've got to depart from this point going parallel to that axis. Okay. Likewise, when I get to here, I have to be going not, a direction like that, right? That's way off. I have to be going in a direction parallel to that axis. So, in fact, I didn't get that. There we go. I have to be going parallel to that axis. Okay, so keep both of these points in mind as we draw this this circle, this quarter circle here that goes, from that point to that point. That quarter circle. Yeah, that started off pretty good, and then I just didn't quite end that well. Maybe something about like that. And now let's check and see if that which is supposed to be parallel actually is. That tangent line is looking good. This tangent line, not bad. Could be better, but not bad. Okay. All right. So we're not far off. We've made a lot of progress on this. Let's look at our picture. By the way, I'm going to get rid of some of these points that we're looking at here that are kind of taking up a bunch of space. Get rid of those. And that. Okay, so not terribly far off. Here's the shortcoming with this picture now. Well, of course, I didn't quite meet up there, and I didn't quite meet up there. Those points were kind of getting in my way. Okay, the big problem, though, is happening down here. So I can see that I've got an edge. There's an edge there, and I know that edge proceeds all the way over to the origin. And I've got an edge here, and that edge proceeds all the way over to the origin. Problem, though, is that that at the origin, at that point, at the origin, that's actually on the back side of this surface as I'm looking at it. So think about this this front face surface here. There's all these sort of lines, you might say, coming down. All that surface is on the front side, but those lines, those lines, they sort of dip under. They go behind to get over to that origin point. Right? So said differently, there's a horizon line, right? In between this edge and this edge, this edge, where the surface kind of wraps behind itself, I need to actually draw a horizon line. Okay, now this is a little bit delicate, so I'm gonna kind of try to redraw my entire picture. Again, I have a lot of little bumpy, wiggly edges there that I want to fix. So let me redraw the entire thing very quickly, just for cleaning up purposes. So we have that. I didn't really curve that well, did I? Let's try that again. We have that. We've got to tangent that in. We have that edge there. We've got to go over there like that. We've got this parabola there. We've got this circle there. And there needs to be a horizon line drawn about like this. Something like that. That's where you can see that we've got surface back here. That's on the back side. That's obscured, you might say, by the front side surface, which is all this stuff there. Okay. So now let me take that off of the color here. I'm going to do get this into green. Maybe do something like that. Okay, now it's looking a little bit more sort of full down there. And now I see a different problem. Yet another problem. This part of this curve now, the part of this paraboloid that's on the back side of the horizon line, that, being obscured, should not be drawn as a solid line. I now realize, and I just didn't think this through, and we didn't have a chance to have thought this through before this point, that should have been a dotted line, not a solid line. And notice that that's creating a kind of a confusion in what this looks like down here. Let me see if I can get this erased. There we go. Sort of a little bit of a mess as to what's going on down there. So I need to turn that into a dotted line. So really, you get right down to it, I need to kind of redo this whole thing over again. I need to draw this parabola here in such a way that I sort of stop about there, and then everything is sort of dotted after that. And likewise, here's where the horizon line hits there. I need to go solid and then dot on either side of it there, on the other side of it there. Okay. All right, so here we go. Oh gosh. You know, I'm just going to start the whole thing over again because I have a big mess going here. So here we go, starting over. Let's do a better job on hitting that. Okay, so my first parabola here, I'm going to go down to about there, and then everything's sort of dotted after that. And then the second parabola, there's going to be where my horizon line goes. It's everything is dotted to there. And up to about like that. And then we have horizon there. And circle there like that. This is getting to be a pretty reasonably good picture. Probably plenty good enough for our purposes. We can see that parabolic side there, that parabolic edge. We can see this parabolic edge. We can see that this part of the surface is in the back, as indicated by those dotted lines. We can see that horizon line, which is where the front side surface sort of turns into that back side surface. And everything that's that should be parallel to something is approximately parallel to what it should be. So again, not perfect, but reasonably accurate and no major flaws at this point. Okay, so notice how that's a process. It took us quite a while to get that figure drawn, and we had to erase and start over. And of course, I have the advantage of using a stylus where I can just erase like that. But as students, though, you have pencils with erasers, or if you're drawing with a pen, then you can just scratch it out and make your next figure. So anyway, think in terms of going in stages. You draw something, you learn from it, then you draw your next attempt better. Okay. All right. Last example here. So this is a tricky one as well. I want to talk about how to draw a solid that's bounded by these 5 planes. And at a glance, this looks terribly difficult. There's a temptation to think, am I actually going to have to draw all 5 of these planes? I mean, you could sort of visualize, well, there's one, and there's one, and here's a different one, and here's a different one, and am I going to really have to draw these 5 planes and try to see somehow through this mess, what's inside of where? That seems insurmountable. So the good news on this problem is that there is a trick to this one. And this kind of thing comes up surprisingly often, so be on the lookout for this sort of a trick. Here it is. These first 3 equations. No y's anywhere in any of those first 3 equations. So that actually tells me a tremendous amount of information. Now let's start with this one for no particular reason. I'm going to draw a picture of that plane, and what I get out of the fact that there are no y's in there, convenient upshot, is that plane is parallel to the y-axis. Now here's how I know. If I were to have some point on that plane, right, satisfies that equation. And now let's suppose if I were to move parallel to the y-axis, right, so here's a point that satisfies that equation. If I move parallel to the y-axis, x doesn't change, z doesn't change, and therefore this next point here also still satisfies that same equation. Okay, so whenever you have a point on that plane, moving parallel to the y-axis keeps you on that plane, and therefore the plane is parallel to the y-axis. Okay. Of course, you can also think in terms of the normal vector. What direction does the normal vector point? Persuade yourself the normal vector has to point perpendicular to the y-axis, and then you get the same conclusion. Okay, so what I'm going to do then with that idea in mind, with these 3 equations, I'm just going to draw what they look like inside of the xz plane here. If I know what they look like inside of the xz plane, then I know that the actual picture is just whatever that is, and I'm just going to drag in both directions parallel to the y-axis, and that'll give me the how those first 3 planes intersect. And inside of this xz plane, it's pretty easy to see what these equations are. Let's just take these one at a time. Z equals 0. Boom, here you go, no problem. It's that line. Let's see here, z equals x. Okay, no problem. It's a line kind of like that. Right, and then finally x plus z equals 2. Well, no big deal. That's a plane kind of like that. So the intersection of these first 3 planes, I just have to look at how do these lines intersect. That's pretty straightforward to see how those lines intersect. Those lines intersect just in this triangle. And that triangle then is what I have to drag in the y direction. And now that I've made a mess, let me clean up my picture a little bit and draw it a little bit more cleanly. I'm going to take that triangle and drag parallel to the y-axis. And I'm going to drag it this other way too. Okay, so we're 60% of the way there due to this clever observation. Okay, now moving along, the last equations, you are just going to have to draw those planes the old-fashioned way. Conveniently, these aren't that bad. Y equals 0, of course, is the XZ plane. That's this. And now let's think in terms of, how does this purple plane here, how does that intersect with this triangular, this prism, this green prism that I have going on that was parallel to the y-axis. And that intersection, well, it's actually what I've already drawn. It's this thing right there. Okay. And then now lastly, what about this? X plus y plus z equals 3. So, well, again, you can take this as a problem with equations of planes. Think about the normal vector, etc. You can also notice that it's not hard to persuade yourself of where that intersects the three different axes. This intersects the three different axes when, well, on the one hand, when x is equal to 3, and on the other hand, where y is equal to 3, etc. So that plane intersects the axes. Let's see here, I have to extend this on a little ways. Intersects the axes at, well, here's where x equals 3, and here's where y equals 3, and here's where z equals 3. Well, I'm going to give myself a little bit more space up there as well. Oh, come on. A little bit more space up there. Where z equals 3 is about right there. So that plane put too much bend in that. About like that. Okay, now here is another situation where you're just going to have to sort of think three-dimensionally. How do these things intersect? I mean, how does this blue plane that I've drawn here representing that, how does that intersect with this green prism that I'm taking a slice of? And it's a little bit of a challenge. This is a hard thing to think through. One sort of a foot in the door on thinking about this, though, is to notice that this point is an actual intersection, right? That is, this green line that we have here, that's inside the XY plane, and this blue line there, that's inside of the XY plane. So where they intersect, that's an actual intersection between the green prism and the blue plane. So that intersection is going to be, it's going to include that point. Likewise, it's going to include that point. Right. So the remaining question is where does this blue plane intersect with this line here? Where does that intersect with that line? Well, this that's not really, that point there is not where it is. That blue line is in the YZ plane. The red line is not in the YZ plane. You can see it's offset from the YZ plane significantly. So where that red line intersects, well, it kind of comes out a little ways from the blue plane, and I'm going to just make a geometric appeal that it's going to intersect somewhere kind of closer into the middle, closer into the middle of that blue plane, where I actually haven't drawn anything, but it'll be somewhere in there like that. So altogether then, where the blue plane intersects that green prism is going to be something like this. Oh gosh, but again, put a little bit too much bend in at, there we go, nice straight line. Okay. All right. So now, still not really quite done. We have been doing a fair amount of erasing and, looking at the picture, learning from it, realizing what we did wrong, trying to improve upon it, etc. But as it stands, there's a bunch of stuff in the picture that has served its purpose and is no longer really helping me see what's going on. In fact, maybe making it harder. Let's take a glance here at what are we really seeing here. What is our actual solid looking like here? And our solid is this. There's our solid. All right, so everything else in the picture is just in the way. Right, so what I'd like to do is to be able to isolate just that stuff, just this part of the picture, and then hopefully kind of just get rid of everything else. So I'm going to start this over with a nice clean piece of paper here. We're going to start over from scratch. We're going to reproduce this picture. We're not going to draw anything up there because our solid isn't up there. The stuff that I've drawn there has served its purpose. I don't need it anymore. Ditto, all of this stuff. I don't need any of that anymore, any of that, not that. Just that yellow thing in the middle. That's our actual solid. So here we go. Axes. And we know that over here on the left side, I've got that triangle right there. So we have that. And then let's see, here I'm going to stick out from there a little ways there, a little more there, and then even more there. And then we connect the dots over here, connect that, and that, and that. Oh, whoops. So there, there, and there. So what we have here, we're now finally done. We have a nice, crisp, clean picture of how those 5 planes intersect. It was helpful to develop this in stages. We learned a lot as we, wrote things down and then realized that we don't need that anymore. And we've ended up with a decent picture. Okay.